I'm gonna try to do it in 15 minutes. I'm not going to translate, but I think that this is recorded and you can go back and if you have any questions, we can. It's the idea is that you can look what I'm doing and then you can let it go, watch the video, and probably explore the PDB. So I'm gonna start just by showing you what is the protein data bank. So I wanted to start from the search engine so you can see how do you search for that, right? So PDB or protein data bank. So protein data bank, you go here. What is the protein data bank or PDB? The PDB is an archive or an archivo or a repository. You can find more information about what is the PDB here. If you go to this tab that says learn and guide to the PDB. So in a brief, molecular or structural biologists, that's people like me that we work with trying to study the structure of the proteins. I'm gonna zoom here. We use techniques as the ones that Jesus mentioned, X-ray crystallography. I work with NMR. Why do we use NMR? Because proteins are not in a fixed position. So proteins move around. So we need to understand how they move besides using molecular dynamic simulations. And they use cryo-electron microscopy to get the 3D-dimensional structure of a protein and put it and deposit that information in this site, in the PDB. So everybody can use it for any purpose that you want. You can use it for drug design, to study, to understand this protein. So in what consists a PDB file? And this is something that to me was very, very important. When I took a class in my PhD of molecular dynamic simulations, we opened for the first time a PDB file. So what is a PDB file? So if you open a file, if you go here, coordinates, you find that a PDB file is just a text file that has the three-dimensional, the 3D coordinates of the atoms of a protein. Each atom has each coordinate in the 3D space. So if you open this document, you notice that, for example, you start with atom number 1, and this is the nitrogen of a lysine residue. So these 9 atoms form only one amino acids. So you have the carbon alpha, carbon beta, the oxygens. And here you can see that these are the coordinates. These 3, X, Y, and Z. So a PDB file is just a text document that you can edit, and probably with Jesus and Carlos, you have to edit or modify your file to whatever purpose that you want. There are other information I will show you in a second, but more information about what is the about the PDB can be found here. So this is information if you are interested more in the X-ray crystallography or trying to understand these little details. But how do you look for molecules in the PDB file? The easiest way to look for a molecule is by directly typing here the name of the protein. If you know a protein specifically, or if you're curious, you can search for hemoglobin, and it's going to give you tons of results, right? So it's going to give you tons of different results. But if you already know which protein you want to work with, you already know a code. This is a four letters code that is exemplified here. And if you know that 4 letters code from the paper that you read or the article, you can go directly here and search for it. In this case, for example, I know that the 4 letters code for the main protease of the coronavirus is 6Y2F. And I know this code because I read the article, but I want to show you here. So this is the first entry, and specifically showing me this one. So I'm gonna click here, and the PDB has tons of information, and you find here specifically what is this protein. This is the main protease of the COVID or the coronavirus 2019. You can find information. This is a viral protein. The expression system, for example, sometimes you use E. coli cells. You can use insect cells to express a protein or to produce it in large quantities. You can find information about the authors. These people were the ones that deposit or put this information in the PDB. You can find information about the resolution. This is important for you if you're doing, for example, molecular dynamic simulations. Sometimes the side chains are not very specific, so you need to be careful about some assumptions about where is the side chain position in your structure. You can find also, this is something cool that I wanted to show you. This is, you find a link through the article that this structure was published. So in this case, this is the title of the article. This is the list of the authors. And something cool that you can find is that the PDB has a direct link to the PubMed. So I'm opening this in another tab. And here you are directed to the National Library of Medicine. This is a public website that uh, if you know English, you can take advantage of this website because you can have direct access to these informations. And you can find the abstract here. And most of something very, very important and that we can take advantage is that because this research is done with US taxpayers' money, so this information is sometimes available for us. So if you see this sign, you can go directly to this article and it is free. And you can go and read it. So that's kind of something cool. Otherwise you can read these articles. Otherwise, if you try to find it through science, you have to pay like $35. So this is something cool from that you can have information directly from the PDB. Other type of information that you can find here is the number of the. You can find information, for example, about the primary, secondary structure. This is the length of the protein. This is you can find information. These are other things. For example, this is something that we will need to use when you use for your docking. Sometimes these proteins are crystallized with some ligands, and these ligands, in this case, is an inhibitor. They have an ID at the same as the protein. They have an ID. This is O6K for this inhibitor. And sometimes these molecules are also crystallized with other molecules that help in the process of the crystallization, the methyl sulfides. And you can find more information here that is only if you're an X-ray crystallographer, you will need this information. But one of the most important things that I want to highlight or show you here is that you can take advantage of the PDB using a tool similar to PyMol. If we go here to this tab that says 3D view, somebody has a question there. I will go ahead and answer those questions in a second. So if you go to this 3DB tab, you can have a program like PyMol that you can visualize a protein. And this is very helpful if you look at Carlos' video. These programs behaves, or you can use the mouse in a similar way to PyMol. So you can rotate the molecule, zoom in or zoom out, And in something that I want to show you here is these different types of representations that Jesus briefly mentioned in his presentation. So this molecule has like a heart shape, if you can see it, but this molecule is a dimer. So in the crystal structure, this you're gonna find monomers or a single unit. So you can change that by the type of the representation. If you go here and you say a model, you will find the monomer. So I want to highlight something here that is very important. Uh, that is the type of representations. So there are four main type of representations that I want to show you or highlight. One of them is this ribbon or cartoon representation. This is the most famous one that Jesus mentioned. Each of them has different advantages and disadvantages. This one, for example, allows you to see the secondary structures. You can see that there are some beta barres here or beta sheets and some alpha helices. But there are different but this molecule is not empty, right? There is no empty spaces in this molecule. So you can look at that by changing the representations. If you go to this tab, to the polymer, so you have different things. So you can change the polymer, so that's the protein, the ligand, and these water molecules. These water molecules are these red dots that are here, so we can delete them or hide them. Just like this is supposed to represent an eye. So if you click there, you see these water molecules are being removed. So now if we go to the polymer and to these three dots, you can change or add a representation here. So the other one that I want to show you is called ball and stick. This ball and stick now is superimposed into this cartoon representation. So we have two representations. So what we want to do is to change that. We're going to hide the cartoon representations, and we are going to show you now this ball and sticks. So this is a very busy image. So es muy tiene muchos detalles. So we don't need so much details in this structure, but this is sometimes good because, for example, when you are looking at the interactions between the ligand and your protein, so you need to know this, what residues are forming there, forming interactions. So some of them has some advantages and disadvantages, and depending on how you combine them, you can maximize or take advantage of these structures. The third representation is called uh, space field. A space field allows you to see a more realistic structure of the protein, and this takes in account the van der Waals radii of each atom. So this molecule is not empty, right? So it allows you to see it. This is the surface that is taken up in your cell or in space. And the last one, that is the one that is my favorite one because allows you to visualize the interaction with your ligands or inhibitors, is called the molecular surface or surface representation. So if we click on this one, this is going to take a few seconds more because it takes more graphic power to load it. Now this molecule, we have other representation here. If you want to hide these other ones, ball and sticks and space field. Now you can see that this molecule has crevices, tiene hoyos o cavidades donde el ligando interactúa. So the ligand is interacting here in this cavity. So here you can see how it's very powerful combining two different representations. You have a surface representations with your ball and stick representation for your ligand. Now, something that you can do using this software or the PDB is that you can change the color, and something that this is an advantage for your presentations. You can change the color to highlight certain feature of your protein. For example, in this case, we're going to change the color. So color cartoon representation, if you go here, you can change the cartoon representation. Set coloring, you go to this tab, set coloring, and then you go to miscellaneous and interaction type. Now you can change the color to white and you can see more contrast with your ligand, right? Now, if we want to see how is this ligand interacting with in the cavity, cómo interactúa el ligando en el sitio activo, so you can change that. You can change the representation of the ligand. So you go here to the ligand tab, and we change the representations to, for example, ball and stick. No ball and stick. We change it to space field here. There you are. See, now this allows you to see that this ligand is forming contacts or is in immediate contact with the cavity of your protein, right? So to me, that was kind of cool. So this is what I wanted to show you. Also, by moving or hovering around this protein, you can see that each residue is being selected. So you can see that, for example, some of these amino acids at the interior of the protein, for example, there are going to be some hydrophobic amino acids. We have phenylalanine, and this is being highlighted here in this top. You are selecting the amino acid. So this is kind of cool. It's something that you can use it if you don't want to install PyMol, or if you want to suggest it to some of your friends. You can take take screenshots and put it in a PowerPoint presentation or something that you learn. So this is one of the coolest things that I wanted to show you from the PDB. And I'm gonna move on because we are running out of time. Something really cool from the PDB is a section that is called PDB 101. In the United States, every class that is an introductory class has the 101 tag. So you can have biology 101 or chemistry 101. So this is going to tell you, this is mainly for fun, right? So you're going to learn more about what is the PDB. So some cool things that I want to show you here is that, for example, you can have a lot of resources about information, and something that I really like is something called the molecule of the month. Every month they are featuring a different molecule. They can have proteins that are related to health and disease, biotechnology, more molecules that are important for life, like ribosomes and proteins, everything. You can find a lot of information here. But something that Valentina mentioned, and I really like about this part also, is you can find a lot of resources. If you go to Learn and Paper Models, you go to here to this tab, and you can find a lot of things to do even for kids of high school. I worked before in a challenge creating an antibody. So this is kind of cool because you can find this antibody here, and you can find information about the antibody, and you can download this template. I'm gonna open this tab, and this is the information. You can print all this information, and then try to assemble this all these chains. And this is not, you realize that by playing you're learning a lot about the 3D structure. You have to, for example, you have to connect the structure, and it's not easy. And then when you guys were talking about the folding, you will realize that it's a very complicated process. Then you have to add these disulfide linkages. So how are you going to do it? And this is going to give you a lot of insight on how the protein folding happens. So this is all these instructions. So I think this is a very nice way of learning about proteins by playing. Other cool thing, other models, and Valentina already played with 3 of them, but this is another one that is a classic one, the beta barrel. This for GFP. Martin Chalfie from the University of Columbia and other two guys discovered the structure or the function of this protein. There's a green fluorescent protein. So this protein has is a beta barrel with anti-parallel beta strands. So by doing and assembling these simple models, you can play and you can realize how these molecules are formed. So this is kind of cool. So you can do that. There are videos. You can post your videos, share it with us. That will be really cool. Other resources from the PDB are videos. There are tons of videos about how proteins work. What is a protein? This is one of my favorite ones. And also you have some gifts. For example, 2 years ago, Jesus and me, we were teaching a club in Mexico, and we used PyMol to create a GIF from a molecular dynamic simulation. So you can create this type of GIF also with PyMol. So using structures from the PDB. And lastly, something that I wanted to show you is a part that is very familiar. I noticed that some of you are artists. So the PDB has a section that is called Science Art and highlights two authors. One is David Goodcell. David Goodcell is the guy that color all these beautiful structures from the PDB. So every molecule of the month feature is showing his work. One of the most famous figure is this one called from E. coli, and you can see how this author used these representations to show how complicated is the interior of the cell in a simple cell as an E. coli. So David Goodcell is a professor here at my institutions at the Scripps Research Institute, and also in my building. There, all the walls are depicting his work art. So that's really cool. And I can show you. I'm fascinated about this art because I love art and I like drawing too. So I wanted to show you how you can also using science, you can combine your passion with these things. So I wanted just to briefly show you some of my work, just to show you how you can combine art. I like drawing. I started drawing just with pencil. This is one of my friends, and then I started putting color because I was like, okay, I need to put some color, and I started playing with color. This is my mom, and this is a professor where I was going to do a postdoc. So I drew her on a magnetic field. So these are supposed to be magnetic field changing, and this is an NMR spectral results. These are cross peaks. This is my dad, and also I wanted to start to combine my passion for science. So I drew this alpha helices coming out from this skull. So I really like this kind of idea that was kind of thinking or exploding. And this is me. I was like, I wanted to combine my passion for Mayan art, and I tried to put some hieroglyphics here in my head. This is me, and I'm speaking the language of proteins, and this is a beta barrel. And even I tried to put my shirt using these structures. So this is just something to show you that you can find a lot of resources here in the PDB. It's not only about proteins. You can find information also from vaccines and so many things that you can learn with it. So I think this is it. I don't want to make it longer, and so I'm gonna stop sharing and try to answer some of your questions. So I'm gonna look at the questions now. So okay.